The last part of 4.4 is working with something called the second fundamental theorem of calculus. Not nearly as used as heavily as the first fundamental theorem, and actually kind of incorporates some of it as well. So the second fundamental theorem of calculus is going to specifically work with an indefinite integral that has a variable boundary. Could be just one boundary, usually the top boundary is the most common, or both boundaries, often having the other boundary being a constant. That's still a definite integral, but we would say it's a definite integral that's written actually as a function of x. So here's what the theorem says. The theorem says as long as you have a continuous interval, then the derivative and the integral essentially cancel each other out. Because if you think about what derivatives and integrals are, so if you look right here, this right here is indicating you're deriving, and then right next to it, this is indicating indicating that you're integrating. And if I derive and then integrate back to back, you should get what you started with. You should get that original function. Now you'll notice the one change is because we'll be putting boundaries into that function, instead of thinking of it as f of t, where your variable's t, your final answer will be f of x. So for example, if you were asked to derive the integral from 8 to x of t squared plus 2, you would just get x squared plus 2. And you could actually prove that by doing the long way, integrating t squared plus 2, because you know how to integrate that. Put your boundaries in, so do a fundamental theorem, and then turn around and derive what you get, and I promise you will get what you started with, because derivatives and integrals cancel each other out. It's like adding and subtracting, or multiplying and then dividing. Well, there is a little caveat to this that often gets kind of picked on the AP test, and that's if you are plugging in a boundary that is not just x, but it's written as some function of x. So instead of x, it's maybe x squared, or 3x, or 5x plus 2, where you have this function. And notice this lower one is kind of showing you that. So you still will be taking that function and replacing the t with it. But you also have to think of this almost like a chain rule. I mean, that's essentially what it is that you also have to multiply by that inner layer, the derivative of what's inside. So you're going to have to, after I make that substitution, multiply by the derivative of the boundary. I didn't have to do it up here for the basic type because the derivative of x is just 1. So when I put it in and think about the derivative, it doesn't change anything. These are going to be the ones they're going to put on the AP test because they want to make sure, again, you pay attention to little details. So let me show you some questions that I have from past years, and then I'll also show you some of the ways that it's worded on Delta Math. These are in no way long problems, but they do make sure you're paying attention. So the most basic application is they're asking you to derive an integral, and your boundary is just x. So you're going to put the x in where the t is, and that is your answer. A lot of times students will say, what about the constant? Why are you ignoring it? Well, here's why I'm ignoring it. Because if I put that constant in, I will get a constant. And then when I derive that constant, I'll get 0. So that's why the constant is never discussed, because the derivative of a constant is 0. So I only care about variable boundaries because they're the only ones that you're actually left with something when we derive. The next one kind of shows you more of what they'll do on the AP test. So again, the derivative and the integral cancel each other out. So you're going to replace your t with 5x. And I'm sure that would be one of the answers on a multiple choice test. You also have to multiply by the derivative of the boundary. So the derivative of 5x is 5. You can put it anywhere you want. Probably makes the most sense to put it in front. Again, the reason we don't deal with the constant is because if I would actually integrate and put a constant in, it's a numeric value, not a function, and the derivative of it would be 0. This was some of the ways that Delta Math presents it. Some of them are presented just like the two that I just did, where you'll have this derivative symbol, you'll have your integral symbol, you are replacing your t with your variable boundary. So you'll have the cosine of 2x being squared. So I am going to square that out and say that's the cosine of 4x squared. And then you are multiplying by the derivative of the boundary, which is 2. Again, I don't need to worry about this constant at the bottom because the derivative of it will be wiped out. It will be 0. Another way that they'll present it on Delta Math, and I've seen this on AP tests as well, so I'm glad they show this presentation, is they'll say f is equal to a definite integral of some function, and then it'll ask you to find f prime. This is the exact same thing as putting a d over dx in front by putting that prime symbol. So again, I am going to plug this in to my function. And often they'll give you one that you actually can't integrate by hand. They'll put this really messy function that you have no way of knowing how to integrate. Sine of 4t plus 1, you don't know how to do it yet. You will, but you still don't want to mess around with it if you don't have to. So I'm going to replace the 4 times t with 4 times the square root of 2x plus 1. But then I also have to derive my boundary. So I'm going to do that work up to the top. My boundary is 2x to the half. So it's like a chain rule in itself. So power out front, power 1 less, derivative of what's inside. The half and the 2 will cancel. So you are left with 2x to the negative 1/2, which if you want, you could write it as a square root of 2x in the bottom, or you could put the 2x in parentheses to the half, but it is in the denominator because of the negative exponent. So it's kind of like a chain rule inside a chain rule. Here's the last one. This is another one I pulled from Delta Math. I felt like I wanted to get away from a trig one. So again, deriving an integral, meaning my boundary is going to take the place of your t value. This actually has to go 2 places. So I'm going to get the square root of 2x to the 3rd squared would be 4x to the 6th plus 2 times 2x cubed would be 4x cubed. And then I need to multiply by the derivative of the boundary, which is 6x squared. The one thing that I'm not sure on Delta Math, they may make you simplify this. For example, you could actually factor out a 4x squared, leaving you with x to the 4th plus, actually you could factor out a 4x cubed, x to the 3rd plus 1. And you actually can take the square root of 4 and then an x squared. So you could bring out a 2x times your 6x squared. I don't know if they'll make you do this. I know on the AP test they won't, but they may on Delta Math. So you can have a 12x cubed, and you would still have under your square root an x and an x to the 3rd plus 1. Again, I don't know how far they're going to make you go. I do know that if you don't put the derivative of the boundary, you're definitely not going to get it right. As far as the algebra simplifying, I'm not going to make you go super far on that.